Good afternoon, everyone. Very warm welcome to another one of our GCSE Maths networks today. As Ellie said, my name's Seb Brummel. I'm a product manager for the GCSE Maths team here at Pearson EdXL. So today's network is on Key Stage 4 bar modelling, a deeper dive. And we have previously run a session on Key Stage 3 bar modelling for beginners. And I'll pop the link to that one of the recording of that session in the chat as well for your reference too. So once again, though, we're delighted to have with us Naomi Bartholomew-Millar, who will be leading us through today's event. Naomi, among a host of other things, is currently head of STEM at a secondary school up in the northeast of England. Naomi also heads up the maths arm of Pixel, as well as leading the curriculum development for the alternative provision in that network. So Naomi has worked as a credible specialist for us at Pearson for a number of years as well, delivering training and support to schools all across the country. So you're in very good hands today. I want to let Naomi get right into it this afternoon, as we've got a lot to cover. But just a bit of housekeeping, as Ellie said. So to ask questions directly to Naomi or to contribute to any of the discussions that Naomi leads, please do use the group chat box. But if you are having any technical difficulties that can't be resolved with a refresh of the browser, let us know in the Q&A and we'll get you sorted out. And similarly, if you've got any questions for me, then the Q&A box is the place. I'll be monitoring that throughout today's event. And I'll do my best to answer anything that's on your mind. So yes, following the event as well, we will be sending out a summary of the presenter slides as well, so you will have that to be able to go back and cover over anything that you may need to after the event. But that's all from me, and with that I'll hand over to Naomi for today's session. Naomi, over to you. Thank you very much.
Thank you very much, Seb, and good afternoon to everybody. Please do use the group chat, like Seb said. There's a nice little group of us here today, so please do ask any questions. If I'm going too fast with any of the examples, then please feel free to tell me to slow down in that chat. If we were doing this in person, obviously it'd be much easier to see what people were doing and how people were finding it. So just to crack straight on then, so this is bar modelling Key Stage 4 deeper dive, looking in a bit more detail at those higher end questions, those ones that students have found particularly difficult. The aim of the session is to just have a very, very brief introduction to the research. I don't know how many people from this session were in my initial section that was, like I say, the groundwork, the basics of it. So just a quick reminder about some of those basics from that session one, but that is just very brief. Then looking at using bar model for ratio, bar model for fractions, those combination questions that catch students out every single year. And then if we have time, some work on solving equations. But I don't want to rush any of these sections, but I am happy to share any of these bits and pieces with you as well. All of the questions that I'm using today, bar a couple of the example ones, are all ones that have come directly from GCSE papers, from the crossover questions or from the higher paper, so that you have access to those as well. And I believe that people will send a PDF of some of the questions as well, so that you've got those in front of you. But don't worry, if not, they'll all be up on the screen as well. So just very briefly then, before we start looking at the nitty-gritty of the questions, I just want to flag this up again, the EF guidance, the Improving Maths in Key Stages 2 to 3. Now, I know this is a deep dive looking at Key Stage 4, but I think it's really important that we understand where it's come from, where that need at Key Stage 4 has come from, and if we can get it right in that transition Key Stage 2, Key Stage 3, then actually what I'm finding now is I'm able to tackle questions which previously I wouldn't have even thought of using with Year 7, Year 8 until much, much later on in Year 9, Year 10, Year 11 even, that now we're actually using them in Year 7 because they've got a really clear understanding and grounding of what this sort of process is. So if you haven't seen this already, there's the 8 strands within there that are sort of suggested ideas of how to, or strategies for how to improve that Key Stage 2 to Key Stage 3, but I do think a lot of these are applicable right the way through, very much so. The two that we're going to concentrate on are actually 2 and 3, strand 2 and 3. So strand 2 is all about manipulatives, which manipulatives you might use. Now, when we did this initially last year, we were well in the middle of lockdown and we were talking about not being able to actually physically have any manipulatives. And bar modelling sort of bridged that gap really. It allowed us that opportunity to have something on the board that we couldn't have in our hands. I would say that the use of manipulatives and bar modelling with the representations, if you can actually have something physical, even if it is the mini whiteboards. I love mini whiteboards so that students are actually drawing the bars as we go. And you'll see later on as well how we can perhaps use counters as well. They don't give, it says there about manipulatives and representations are just tools. It's how they use that's essential. They don't give the answer, they just allow students to see how that answer can sort of be found. It's their method of problem solving. And then strand 3 is all about problem solving, having that problem solving strategy where there's something which is unknown for students, that they can then apply that process, that strategy to a variety of different contexts. And this is where, for me, I think bar modelling has been the most transformative in terms of my practice over the last, I don't know, probably about 4 or 5 years. I first sort of was introduced to bar modelling around 2016, 2015. And since then, I would say it's now become my go-to for as a problem-solving strategy for students. My first question is, can you draw it? Can you draw me a bar model to help you answer this question? Okay, so my first question really in the chat, if you can just sort of write in there, just so I can get an idea of the sort of, you know, how confident are you with bar modelling? Did you attend the first session that I did? Is it something that you use regularly, perhaps with Key Stage 3? Is it something that you're just now looking at how you can apply it higher up the school? So just sort of how confident do you feel with bar modelling? Just a couple of thoughts in the chat for me for a minute. Okay, so we've got someone that attended the first session. That's great. Okay, limited use, that's fine. Okay, I'll keep an eye and see if any more come through on that one for us. I'll get more confident. Yeah, so perhaps started to use them mainly Key Stage 3, but looking at possibly moving it up to Key Stage 4 ratio. Yeah. A new strategy for the department. Okay, good, excellent. Right, okay, so that's really good. So sort of a roughly around the same sort of level, I would say. So just as a quick reminder then about the purpose of the bar modelling, why we would use it. So students, first of all, make the use of the concrete objects when they're in sort of lower down the school, and in primary school they have things, they're counting things, flowers, apples, whatever it might be. And then what we want them to do is then make this into a visual representation, that pictorial part where they're drawing those rectangular bars, and then using that to identify the maths that goes with it. So like I said, the bar model doesn't answer the question, it just shows them the method that they need to use, the strategy that they then need to use in order to be able to access that question. Oh, that's interesting, using them for Pythagoras and solving linear equations. Okay, so as a quick reminder then of some of just a couple of slides just on the quick reminder of things that we did in the first session. The multiplication, don't rush this link. Even if it's something that you need to go back to with your higher students, GCSE classes, remind them about multiplication, remind them what this means, this idea of like the 20 with we've got 4 lots of 5, 5 times 4 is 20, what else do you know, 20 divided by 5 is 4, and so on. That for me is a really key part of it. Talking to them and then as maybe talk about in terms of percentages, what percentage that would be and so on, what fraction has been split up there with that multiplication, but anything at all that they can tell you from that picture. So that for me, the understanding that whole is 20 and those parts are 5 is really crucial to then being able to apply that to a whole host of different then applications. Adam is banned in my school. I do have a member of staff called Adam, and he was chuckling when he saw me printing this off yesterday, because Adam, that add, divide and multiply is a, I've got a student teacher coming through at the moment who came with this idea that I've got, Adam, we add, we divide, and we multiply. We absolutely do not add, divide, and multiply. That is a trick that only works in some situations with ratio, and students get themselves in a muddle. And you'll see in a minute, we're going to do that pens question, that famous, the one with the, I think it's 2019, the one with the red, the green pens, and they can't add and divide and multiply. It just doesn't work. And so few of those ratio questions that they now have to do in GCSE actually work with Adam. So avoiding those tricks, making them understand the structure behind what it is that they're doing. Okay, so Josh and Ben share some marbles in the ratio of 2 to 3, and Ben has 21 marbles. How many marbles do they have altogether? So I'm just going to switch to my screen, so from this point onwards, so I can draw. Okay, so just making sure that we're all clear on how we would do this. Just on your piece of paper that you've got there, you are going to have to do quite a bit of maths tonight, I'm afraid. Can you draw for me, please, what this would look like, how you would set this up as a bar model? Okay, so I always talk about telling the story. So we say we've got Josh and Ben. So that's the first thing I'm going to do. Josh and Ben happen to be two of my brothers. Josh and Ben, there we go. And they're sharing some marbles in the ratio 2 to 3. So we're going to tell the story of what we can see. We've got two boxes for Josh. And we have 3 boxes for Ben. And then he says Ben has 21 marbles. So then we say, right, well, Ben's got 21 marbles. Where is that? And that's this bit here. So that's 21. So now I always say, if you're thinking it, if any calculation that you're doing, you still write that down. So now I've got these 3 boxes that represent 21. So I know I need to do the calculation 21 shared by 3, which is 7. So I've written down that calculation. I've not just done it in my head. I've written it down to show I understand what I'm doing. And then my question says, how many do they have all together? Well, what calculation am I going to do there? I'm going to do 7 times 5, which is 35. Now, even with simple ones like this, get them into the habit early on of showing these steps of these working out, of showing what calculation it is that they've actually done. So then we've got 3 more questions here, and I've picked these questions deliberately because they look the same. And think, sort of putting your hat on as though you're a student, if you were reading these, what would you do? What do you think a student would do? What would they miss? What would they see? So for each one of these, Ben and Josh share some marbles in the ratio 2 to 3. The first question says that Ben has 20 marbles, and my question is, how many do they have altogether? So again, if I'm going to do that one as Ben and Josh, with 2 and 3, and this time I'm told that it's Ben that's got 20 marbles. So which bit is that? That's this bit here. Oh, not quite giving myself enough space there. 20. So what calculation am I doing? I'm going to do 20 divided by 2, which is 10. So I now know that each box is worth 10. And now I can answer the question, how many do they have altogether? Well, that's 10 times 5, which is 50. Now the second one, same starting point. They still have, Ben and Josh are still in the ratio 2 to 3. But this time they have 20 marbles in total. So all of that is worth 20. So then I have to think, right, okay, so what calculation am I going to do now? This time I've got to do the calculation 20 divided by 5, which is 4. So this time I know that each box is worth 4. And this question this time is, how many does Josh have? Well, Josh has 4 times 3 boxes, which is 12. And then this one is the sort of thing that we're seeing a bit more often, that there's a difference in them. So again, Ben and Josh sharing in the ratio of 2 to 3. But this time though, Josh has 20 more marbles. So we mark on our diagram where that would be, which is this bit here. Just happens to just be one box. So then we know every box is worth 20. And then again, we'll go back to my question. How many do they have in total? I've got 20 times by 5 boxes, which is 100. Now I can't remember the correct term for when you give students questions like this, like a variation theory, I suppose, or it's not same surface, different depth, but it's that sort of idea that you give them some questions which look so similar, and if a student was scan reading through them and they tried to do their add, divide, multiply, it would work to a certain extent, but then it would fall down at different points. So giving them 3 questions like that, where they have to really think about what's the story of this question, what is it that this particular question is actually asking me. Okay, now on the next one, if you've got your PDF in front of you, it says Peter has 15 more marbles. That just needs to change into a 12, please, if you've got the questions in front of you. This kind of thing works just as well, even if it's set up as a ratio of 3 parts. So again, we have a look and we see what we've got. We've got Gavin, Sarah, and Peter. So we're going to write down Gavin, Sarah, and Peter, and they're sharing in the ratio 2 to 5 to 8. So draw the 5. And then we've got the 8. And Peter has 12 more sweets than Gavin. I'm going to draw my line down there, and that's representing the 12 there. So that's my diagram, that's my picture drawn. Now I'm going to do the calculation. So I can see that I've got 12 sweets shared between 6 boxes. So I need to do my 12 shared by 6, which is 2. So every box is worth 2. I could go through and write down 2 in every box if I needed to. But actually it's Sarah that I'm interested in. So my question is saying, how many does Sarah have? Well, there's 2 sweets in every box, and there are 5 boxes, so she has 10. So nice and straightforward. But again, this is the kind of question that you can easily now be using in sort of year 7 classes. And if you look at this question, I'm not going to do this question, but a very similar sort of setup. Gavin, Sarah, and Peter share £350. We have a ratio, but this time Gavin has £75 less than Sarah. So again, when you set that one up, you would have a less than part rather than a greater than part, and you're working out what's in each box as you go. Okay, so let's have a look at some GCSE paper questions then. I'm just going to have a quick check on the chat, see if there's any questions come through that I need to answer to. All right, so yeah, I will come back to that one, Gemma, thank you. Just checking there wasn't anything else on that one. Right, so if we go back to this one then. Just starting off with a foundation paper question. That proportional reasoning, 3 kilograms of meat costs £54. Nina bans 2 kilograms of meat, work out how much Nina pays. And again, students get themselves in a bit of a muddle with this kind of question. Not really, even though the numbers actually look like they should be quite nice, it looks like they shouldn't be too difficult. But again, if we think about what that's representing, we've got 3 kilograms. So let's show each one of those can be a kilogram. And that costs £54. And if we want to work out how much 2 boxes are worth, what we're going to have to do first, okay, so I've got 54 divided by 3, which is 18. So every box is worth 18. And then I can work out how much she's going to pay for the 2 kilograms of meat. The David and the Becky question, again, this, if you go onto the Emporium and look in the themed papers or topic papers, sorry, the there is one in here with ratio, this is just ratio questions, and all of these I've taken from there as well as from the exam papers. But there's some brilliant ones like this in there that, again, that sort of idea of, right, David's got twice as many cousins as Becky, or someone's twice as old as this person, and so on. So with this kind of question, what I would do is I'd take the students through it again. First of all, just identify how many people we're talking about. Before we even start reading about what we need to draw with bars, just look at how many names have we got. We've got David, Becky, and Nishat. Right, so that's what I'm going to do first of all. I'm going to write that down. I'm not going to do anything else yet. Right. Now I'm going to think about what I've got. Now, as a maths teacher, I can see that the more sensible option is to start with Nishat. But actually, students don't do that. My experience is that students won't start from the bottom here, won't start with Nishat having 6 cousins. What they will do is start with this first sentence here about David. So that's what we're going to do. We're going to do it as though we were doing it as a student. You may get some that can spot that actually starting at the bottom makes it easier. That's not my experience though with this. So David has twice as many cousins as Becky. So Becky's got 1 box. David needs to have 2 boxes. Reasonably confident with that. Becky has twice as many cousins as Nishat. Now, this is where you sort of have to talk through a little bit about, okay, so how could we do that? A couple of ways we could do that. If I give Nishat 1 box, then what I need to do is I need to double Becky's, but then I also need to do that there. You could also have students who've done it before who have split the boxes, who've been able to see that actually if you draw Nishat's box half as big as Becky's, but then you have to split the boxes. If Nishat has 6 cousins, then every one of these is also worth 6. So then we can say, okay, so what's the calculation we need to do there to answer the question is how many does David have? Well, that's 6 times 4, which is 24. Now, like I say, if you'd actually started with this point here of Nishat having 6 cousins and worked your way backwards, then it does make that much easier to draw. But I think that the majority of students that I've come across have always just launched straight in with that first sentence. The slightly harder one then, I've got one of the crossover questions from the June 2019 paper. I know students found this one difficult because we've got a bit of a mixture of ratio in there. We've got a bit of this 1.5 times bigger than Abby. So again, before we even start, we just start by just working out how many different names we've got. A, B, C, D, nice and easy. I'm going to write them in that order. And I can see that the ratio, the amount Abby gets to the amount Ben gets is 2 to 7. Excuse me. So I'm going to draw that. 2 boxes for Abby. And 7 boxes for Ben. And then this bit here, Chloe and Dinesh get 1.5 times, they each get 1.5 times the amount of that Abby gets. So if I now look at Abby, Abby's got these 2 boxes. So if they both get 1.5 times, I can see that reasonably easily from the picture what 1.5 times would be. So it would give me 3 boxes for each of them. So I've drawn all of that information there, and then they've got this little bit here that £360 is shared. So I know now all of those boxes represents 360. So now I can think about, right, okay, so what's the calculation? Well, I can just count up the boxes. So I've got 360, and I'm sharing it in between 15 boxes, which is 24. Okay. So then once I've got that, then the next thing to do is say, right, okay, so what's the question actually asking me? How much does Ben get? So I'll go back to Ben and see how many boxes does Ben have? Well, Ben has 7 boxes. Each one's worth £24. So he gets £168. Now I struggle now to kind of think how I would do this without drawing a picture. So it'd be interesting to go back, perhaps. I know a lot of people have just used the June 2019 paper as their mock in December time, and actually just look and see not only how does the mark scheme mark that one, but how would you have taught that without a bar model? How would you do that? And now I've got so ingrained in bar modeling, I do genuinely find it really difficult to think how I would do this question now without drawing a bar model of some description, without drawing something. From the May 2018 foundation paper, the houses and flats, flats to bungalows. Now, I've picked this one because it was directly off an exam paper. There's loads of examples out there with chickens and pigs and goats and stuff on farms where you're having to do something with these two numbers here. Now, these ones here fall out quite nicely. 4 and 8, obviously, we can see that that falls out quite nicely. And you might have taught it where you double it, so it's 14 and 8, so you're comparing like for like. That works fine for these numbers, but actually this method that I'm going to show you now with the bar model works where for whatever that comparison is in the middle, where the common factor isn't obvious, where one's not a multiple of the other. So it works for much more complicated ones where they would have to do quite a lot of sort of working out lowest common multiples and so on and things like that. So with this one, we've got houses, flats, and bungalows. In the same way, again, sort of I train my students to look for the names or what it is, what is it we're talking about. So we've got houses, we've got flats, and we've got bungalows. So the number of houses, we've got 7 boxes for houses. For flats, we've got 4. And then then our next one is we've got the flats to bungalows is 8 to 5. So again, I'm going to draw the number of flats hasn't changed. I've still got my bar has to be exactly the same size. It's just that it needs 8 bars. Now, like I say, this falls nicely because each one's half as big as the other, but actually it doesn't make any difference. The fact is these bars are the same size. That's the key point. And then the bungalow has 5. So that's how you set up any one of these questions where there's a comparison, and it's about recognizing that in the middle there, sort of the common factor in this, the flats in this case, or the pigs or whatever it might be, the bar is the same length. There are 50 bungalows. So then we look where that is. Well, there's that 50. And this is what I was saying about making sure that is really clear, that multiplication link early on. So what calculation do I need to do at this point? Okay, so I'm going to do my 50 divided by 5. Which is 10, which means that I know that each one of these tiny little boxes here is worth 10. So each one of those flats one there is worth 10. So I've got 10 times 8, which is 80, which means that this here, because it's the same size, and that's the point of these, is that that bar is the same total length, is 80. So I've got to do 80 divided by 4, which is 20. First time I did this with the kids at school, I think they thought I was doing some kind of magic, that this was some sort of sorcery, that this was going to work. And then 20 times by the 7, so we've got 140. So my answer is 140. So like I said, if you've got these kinds of questions where the numbers fall out nicely, they might be able to see that you multiply by 2. But let's say that ratio was something like, I don't know, let's say it was something like 7 to 3 and 8 to 5. You would still do exactly the same method, because it's the point is that the bar needs to be the same size for those two in the middle. It actually doesn't matter whether you can double it or not. Okay, I'll just give you a minute just to read this question. And while I check the chat as well. Any questions, feel free to pop them in the chat. I'll just give you a minute just to have a quick read of this question. Okay, so this is where we're starting to think about our ratio, where there's a change of ratio. And I have got a couple more examples that are not in the PDF that I just sort of put together quickly, because a couple of people contacted me via Twitter. I'm not entirely sure whether they're on the call or not. Contacted me via Twitter after they saw that the advert was out, about how to do those questions where you have an initial ratio and then something changes and you've got the new ratio and you've got to answer a question about what happened at the start. Okay, so we identify our names. So we've got Tom and Adam. and they have a total of 240 stamps. The ratio to begin with is 3 to 7. So I'm going to draw my starting ratio as 3 to 7. And I know that all of that represents 240. So I'm going to think, okay, what can I do with that information? Well, I can do 240 divided by 10, which is 24. So I know each one of these boxes is 24. Okay, so that's all I'm going to do with that at the moment. I'm not going to do any of the calculation at the moment. I'm just going to fill that in like that because that's what I'm comfortable doing. And now Tom buys some stamps from Adam. The ratio now is 3 to 5. So I'm still going to draw Tom and Adam. Now they basically exchanged some stamps, but the total number of stamps is still exactly the same. So there is still 240 stamps in total. They've just swapped some around. So I'm going to do the same calculation, but this time it's 240 divided by 8, which is 30. So now each one of my boxes is 30. So the question then, so I've done all of the working out here, and then I say, right, so how many stamps does Tom buy from Adam? Well, I can work out how many Adam had at the start. So at the start, he had 24 times 7 stamps, which is 168. And at the end, he had 30 times 5, which is 150. Which is 18, so he bought 18. Or you could do it from Tom's. You could work out what Tom had at the start and what Tom had at the end and work out the difference there. But actually, although this is quite a wordy question and there's quite a lot more steps as on most we've had to do in terms of working out, they're not doing anything there that they haven't already done. Students aren't doing anything there with that question they haven't already done. However, I know a significant number of students that got themselves in a real pickle with this question, trying to work out differences in ratios and just couldn't do it. Whereas actually when we showed them like this, when I showed them how to do it like this, it just makes more sense. It just seems to open that kind of question up to them. And even students who you consider sort of quite high ability students aren't sure how to tackle one of these questions, don't know how to start one of these questions. Okay, a question from the June 2019 paper. I'm not going to do part A, so that was to do with lowest common multiples. But again, just give you a minute just to read the question. Okay, so for part A, that's to do with lowest common multiple, but the sort of lowest common multiple, the total of the two ratios are 11 and 8, so the lowest common multiple is 88. But in terms of the bar modelling for this part B here, all the small cubes are yellow. Work out the least possible number of large yellow cubes in the bag. So if we start off with, we've got, what have we got? We've got small cubes, large cubes, red cubes, yellow cubes. Okay, so we've got small and large, red and yellow cubes. So the ratio of small to large cubes is 4 to 7. And the ratio of red to yellow is 3 to 5. Sorry, I should have changed my colour pen really, not done it all in red. So set up our initial bit. Now we know that the least number of cubes that this could be is 88. So if we say, right, okay, well, let's start with that. Let's start from that point of 88. Then we know that in this small bag here, in the small cubes, if we've got 88 divided by, if all of this here is 88, and we do 88 divided by 11, we get 8. So each one of these boxes is worth 8. Which means I have 32 small cubes. And all of those cubes are yellow. So I know I already have 32 yellows. Now if we do the same over here, okay, this is just our red and our yellows, it's still 88. We're still saying, right, well, let's start with that 88. We've got 88 divided by 8 this time, which is 11. So each one of our boxes here is 11. So we've got 11 times 5, which is 55. So in total, my total number of yellow cubes is 55. I already have 32 yellows. So the remainder is 23. So I've got 23 large yellow cubes, the least possible number of large yellow cubes. And again, that's not necessarily going to be straightforward for students, but I do feel that they can start to build up to that kind of question. Okay, I'm just conscious of the time, so I'm going to skip through and I just want to show you this before and after question that I've just put in, that I've just added in. So this isn't in your pack at the moment. Another one of those sort of before and after questions. So the ratio of red to green tiles is 3:5. I gain 15 red tiles and I give away 3 green tiles. I now have the same number of tiles. How many of each tile do I have to begin with? So if we have a look at that, what that would look like, so we've got red to green. I'm going to change to blue pen, sorry. Okay, so we've got red to green tiles in the ratio 3:5. So red to green. Okay, and then I gain 15 red tiles and I give away 3 green. So basically, I have the same. So that means that that's 15 and a 3. It ends up being the same. The size of that bar is the same. So if I've given away 50, I gain 15 and I give away 3 of the green, then it now means that that's the same. I can compare down here and say, right, okay, well that total there is 18. Which means each box is 9, and then I can work out from that how much each of those bars is worth. Each of those is worth the reds and the greens. These questions are sort of becoming more and more common. This idea of changing something, and I think they're probably really hard to do, but actually start to try and think about how to bar model those. Again, just sort of conscious of the time, but I would happily show people. I'm happy to share my email address as well. If anybody would like me to go through any more of that kind of one, the before and after one, I'm happy to show people how to do those. Okay, just want to move on to fractions of amounts so that we can look at how we apply this to those combination questions. So again, in the first session, we talked about what you can see here. What does this represent? You know, a fifth of 20. What does that mean? What does that look like? If a quarter of a number is 15, what's the number? So these were all questions that we did in that first session, that Key Stage 3 session, or the introduction to bar modelling. So becoming really confident with how to show a fraction of an amount on a larger bar and the different types of questions that you can do before you move on to something really wordy. So if 3/4 of a number is 15, what would that be? So you'd have the 3/4 there is 15. Again, it's just all that same principle. You've got a total. What are you going to do with that total? I'm going to do 15 divided by 3. Tells me what each bar's worth. Then I can apply that to the question. This one, I just wanted to show you this one. So you've got 3 meters of wire, and I cut a fifth of a meter off. How much do I have left? And then I have 3 meters of wire. I cut a fifth off. How much do I have left? Now that difference between of a meter off and a fifth off is obviously such a really tiny, subtle difference, but actually makes a big difference to the question. It changes the question completely. So if we just have a look at the 3 meters of wire and you cut off 1/5 of a meter. So what I would be saying there is, because you're doing 1/5 of a meter, I'm going to split this into my 3 meters. So all of that is my 3 meters. I'm going to split it into the 3 parts. Now, if I cut off 1/5 of a meter, what I'm going to do first then is I'm going to split each of these meters into 5. And if I cut 1/5 off there, and I've drawn my picture, okay, so now I can start to think about, right, what calculation would I need to do there to show what is 1/5 of a meter? You know, I'm going to change that into centimeters. I'm going to make it into each one of those is 100 centimeters, each one of those sort of bars there, and then work out what each one of the red ones is, and then take it off. And then with the second part of the question, I cut 1/5 off. That's where we've then got to, right, okay, so if this is all 3 meters, I just need to split this into 5. And they're not going to be nice equal parts there, but they would be if I'd done it on squared paper. And if I cut off 1/5, again, what calculation would I need to do there? Would I need to make that into 300 first and work out that each one of those is 60 and then take that away? But again, I'm really keen on trying to find questions where everything looks almost identical apart from one tiny little thing. And here, it's this bit here of a meter or 1/5 off. And then talking about what's the difference with the bars, how will they look different? Fraction multiplications with bars. Now, there's lots of videos and lots of different suggestions out there of what people do with fractions and how you build up to being able to do fraction manipulation with bars. I'm just going to show you 2 methods now with the 2 of the different types of fraction manipulations for multiplication. Now, I'm a big fan of using the number line as essentially as my bar, but also there is another way of doing it where you show them with a box. I think it's because it's this idea again that when we're doing multiplication, for example, we say top times top, bottom times bottom. And that's again a bit like Adam. It's just a trick. We're just telling them what the rule is, and we're expecting them to remember something rather than really understanding it. And there's nothing wrong with starting off with something like bar modelling and then them spotting the rule and then removing the bars, because they're much more likely to remember it if it's something that they've realised for themselves. So if we were going to do something like the calculation 1/2 times 3, okay, or half of 3, and different ways of talking about it like that. A couple of different ways you could represent this on our number line. I would always do this as, there's my 3, and I want to do each one of those in half. And I'm going to do 3 of those. Okay, so this is how I would sort of probably start with my year 7s or with my nurture group in year 9, sort of thinking about what that fraction looks like on a number line. What is that? Well, each one of those is 1/2. That's 3 halves, 4 halves, and so on. And we talk about things like that as well. So we're starting to build up that equivalence, that they can see, well, that actually makes 3 halves. What's that the same as? What are those red numbers? And just talking around what that bar is. Because then what we can do is we can build that up to doing a calculation like 2/3 times by 3/4. So I want 2/3 of 3/4. So 2/3 of 3/4, that's how I would say that one. So I'm going to start with my number line, which is starting at 0, and I'm going to split it into quarters because I want 2/3 of 3/4. So that's 1/4, 2/4, 3/4, and 4/4. So now I'm going to show where my 3/4 are. So I've got 1/4, 2/4, and 3/4. Now I want 2/3 of that. So I'm going to split each one of these into 3. And then again, you could, if you wanted to, you could put what each one of those is. So you've got 1/3, 2/3, 3/3, 4/3, 5/3, and so on. But I can see I've now split that up into 12 equal parts. So I'm just going to put on there that that's 12 out of 12 equal parts now in those green lines. And then I'm going to say, okay, so I want 2/3 each of those. So what have I got? I've got two 12s there, another 2 12s there, and another 2 12s there. So in total, I can see I've got 6 12s. And then that comes back to you starting to talk about your equivalent fractions. You're talking about, right, okay, well, where does the 6 come from? Why is it 6? Why is it 12? Why did I end up with 12 there? And again, you know, if you've got loads of these on your board and you're building these up and you're saying, well, where does the denominator come from? Where does the numerator come from? What is the generalization? You know, if I had A over B times C over D, what would my denominator be? What would my numerator be? And actually, students quite quickly come to that conclusion for themselves. And yeah, it would be dead easy for us to just say, just times the top by the top and the bottom by the bottom. But actually, unless they really understand it, they're not going to remember it. Or certainly that's what I believe, is that if they can't see it, then they're not going to understand it. They're not going to see where that comes from. The other method for multiplying by fractions, so again, if we do our 2/3 times by 3/4, is to do it as a grid. And again, I would probably have started off this as a quick reminder about, well, what's 2 times 3? How can we show 2 times 3? We can show it as 2 rows of 3s or 3 rows of 2s, however we want to do it. But how we can do this one is if we say 2/3, so I'm going to split this up into thirds first of all. And I'm going to colour in 2/3. And then I'm going to split the other bit up into quarters. So I'm going to split into quarters the other way. And I want 3 of those quarters. And wherever we've got sort of an overlap here, we have 6 out of a possible 12 squares there coloured in. Now again, that sort of leads nicely to the generalisation of where does the 6 come from, where does the 12 come from. I do quite like this as a multiplication. I find that this still to me feels a bit of a trick. I'm not convinced necessarily with this method that students really still understand it. For me, I prefer the number line method. However, I did just want to show you this because I think this is quite another nice way of showing why you have 6, why you have 12, why it's the top times the top and the bottom times the bottom, rather than just sort of teaching them top times top, bottom times bottom. So again, just sort of having a look at fractions on number lines and how we would use those. Okay, so some combined questions then. So again, these are the ones where we start to see the sort of the wheels fall off a little bit with the add, divide, multiply. I'm not being quite sure how they would show this. Men and women at a meeting, 28 women, 30% of them are men. Work out the total number of people at the meeting. So again, we identify we've got men and women at a meeting. So we've got men and we've got women. There are 28 women and 30% of them are men. So I'm going to draw 3 boxes. Each one of those boxes is going to represent 30%. So I know I'd have 7 boxes. Now, some people might do this as just one big long bar, as 10 boxes. That's fine. I have always got into the habit of stacking. I don't know why. I just prefer to stack. And then we know that this here represents 28. So my calculation is 28 divided by 7, which is 4. So therefore, I can now work out the question is what's the total number of people at the meeting. So every box is worth 4, and I have 10 boxes. So there were 40 people at that meeting. Okay, I'll just give you a minute just to read this one because it's quite wordy, this one, if you haven't got it in front of you. I'll just check the chat as well. If there's any questions, just pop those in now. Just while I give you a minute just to have a quick read of that. Yeah, Gemma, so your question there about using the number line and the grid method to explain dividing fractions. The grid method, there is a dividing method for the grid method, but I find it I have to really think about it to be able to do it. So if I have to think about it, I'm not sure it helps the students. However, the dividing on the number line is much easier to do. So yes, I would always use the number line method for dividing fractions as well. Okay, so back to this question then. 60 people in a choir, half of them are women. The rest of the women, the number of women in the choir is 3 times the number of men. The rest in the choir are children. Blah, blah, blah. Okay, too much information for students, too much information. So break it down, slow it down, one bit at a time. Okay, what have we got? Women, men, children. Okay. Half of the people in the choir are women. Okay, and there are 60 people in the choir. Right, so I'm just going to draw a box for women. And I know that that box represents 30. Okay, if I was being correct, I should also do 60 divided by 2 is 30 to show where I've got that from. The number of women is 3 times the number of the men in the choir. Okay, so now I'm starting to think about my bars, right? So this box, I'm going to split this into 3. And that's the men. So I know that each one of those boxes is worth 10. So the men's worth 10. And the rest of the people in the people in the choir are children. Okay, so I'm going to work out what I've got so far. I've got 30 plus 10, so I've got 40. So I need to do 60 minus 40, which is 20. So I know there are 20 children, which just happens in this case to be the same as 2 boxes. And then my question is the number of children in the choir to the number of men in the choir. In the form of n to 1. So that's sort of thinking about now, okay, well, what's one of those boxes? What would one person be? So I can see that that's 2 to 1. That cancels down to 2 to 1. Okay, I'm going to just, again, just conscious of the time, we've just got about 10 minutes left before we've got time then for some questions at the end. I just want to go through how we might use bar modelling for algebra, but also a slight alternative method as well for the algebra. Because for me, I know somebody there said they were using it for solving linear equations, and I think it's a great way of perhaps introducing it. I think it starts to get a bit messy when you end up with negatives and things in it. It starts to get a little bit more trying to overcompensate and it overcomplicates it a little bit, but some people are really confident with using the bar model for solving linear equations, and that's great, and crack on. For me, it hasn't necessarily been something that I have particularly used. I've used algebra tiles instead, which again I thought I would still show you because to me it's still part of the manipulations of the bar modelling. So if we just have a look at this question here, 4 plus 2 brackets x plus 5 equals 20. What would that look like? How would we set that up? Well, it's 4, and then we've got 2 lots of that x plus 5, and the total bar is 20. And then we can kind of move things around a little bit. We sort of expand. We've also expanded the bracket. It is a nice way of showing that expanded, what an expanded bracket would look like, simplified. And then we can take off that 14. Oh, sorry, I didn't realise I was stand on that one. We take away the 14. And then you've got the 2x is 16, so we can see that x would be 8. Okay, so like I say, some people are really confident with using the bar models for linear equations. I prefer to use algebra tiles. Now, before I use algebra tiles, I would have done some work with them on directed number, negative numbers using double-sided counters. Now, I don't know if anybody uses double-sided counters. For me, absolute game changer with negative numbers. If you don't have any physically, use mathspot.com. That's my go-to website for all bar modelling and manipulatives on the screen, particularly during COVID when we couldn't actually use any physical manipulatives. So the first thing I would do is I would talk to them about what number is represented. And you talk about this idea of this being a 0 pair. So if you've got a red with a yellow, it's 0. They cancel each other out. So that number there represents the number 1. This number here is representing the number 3. We've got a 0 pair there, 0 pair there. So this is 3 as well. That's the number 3. And again, looking for 0 pairs, that's the number 2. So you get sort of build up for quite a while, building up about how you manipulate with those sort of counters, what those numbers mean. Now, if I wanted to do with the calculation 3 minus 2, 3 take away negative 2, well, I don't have any negative 2's to remove. I can't physically take away what I don't have. So what you do is you add on 2 0 pairs. This still represents the number 3. This still shows the number 3 because that's 2 0 pairs. But now I've got these negative 2's here. I've got these 2 red counters here that I can now remove. And by removing them, I'm left with 5. So I know that 3 minus negative 2 is 5. And again, this was quite a good way of, when I've done this, I've used this as a way of showing them that rule of that horrible misconception of 2 minuses make a plus. When does it? When doesn't it? But we would have done some prior work first before algebra tiles on using the double-sided counters for the 0 pairs and for how we manipulate with those so that we could show something like this. So the green bar is our x, it's our unknown. We have 3 yellows, we've got 3 positives, and it equals 5 on the other side. Now, one way I could do this is I could see, right, well, if I take away 3 yellow counters from one side, I can take away 3 yellow counters from the other side. Now, that's fine until you end up with your negatives. So what we do, the method that we use at school for this is that we create 0 pairs. So if I want to be left with just x on one side, what I need to do is I need to put those 3 red counters on both sides to create those 0 pairs. And by doing that, I will be left with x equals 2. If we had something like this, where we've got 2x minus 5 equals 9, again, now this is where you can see, right, it's not as obvious as just having yellows on both sides. I can't just move those 5 reds onto the right-hand side because that's just going to get in a mess. I need to create 0 pairs. So what I've done there is I'm just going to add on 5 lots of yellow counters to both sides. So I'm keeping it the same, but now I've got my 0 pairs. So I end up with 2x equals 14. So x equals 7. Okay, what about if we've got x's on both sides then? So if we've got x's on both sides, right, this time I'm going to 0 pair my x. Okay, I'm going to 0 pair an x, and I can just bring on 2 red rectangles like that. They cancel out, they keep it balanced because I've done it the same to both sides, but they're going to cancel those out. And now I'm left with x plus 3 equals negative 5. So again, I want to 0 out those yellows. So I've got to bring in some negative reds. I've got to bring in my 3 red counters. They will cancel out, leaving me with x equals negative 8. Okay, so just to conclude then, I'll come back, stop sharing. Just to conclude, what I would say is that whenever we're using bar modelling, use it with caution. I think it's fantastic for things like ratio. I think it's got a real place for those combination questions, those higher GCSE questions that we just had a quick look at there, that will really challenge students. Build it up slowly. Don't rush any of those steps. But really do think about having a go with it. Even those higher ability students, start using it much lower down in the school. Start using those GCSE questions, those combination questions, those crossover questions, right down in year 7 and year 8, because a lot of our year 7s and 8s, COVID, forgetting about COVID, they're coming through primary school with a lot of them with a real secure idea about how to use bar modelling, and then they come to secondary school and a lot of people stop using it and then try and reintroduce it again back in Key Stage 4 when it's almost too late by then to sort of try and reteach them it. So start using it really early on in Key Stage 3. Start with those combination questions. Have a look at exploring the fractions, how we do multiplication with fractions, how we do division with fractions on the number line. And I think we've just got about 10 minutes now then for any questions. How would you move students from manipulatives to the working, or would they show it in exams, or is it just an introduction? Okay, so for some students, they never drop the bar model. So for some students, they will continue to use bar model as their go-to and their method marks in the exam paper. For some students, once they start to realise that idea of the differences that they're working out, that actually they don't need to draw out 8 boxes and 5 boxes, the difference is 3 boxes. They can start to see it in their head, they can start to make that picture. I wouldn't do any more formal methods necessarily. I wouldn't be looking for any more formal methods unless I feel that they're ready for it. Like I say, for some students, I never go any further than the bar model, and there's nothing wrong with that. I think that for those students, that is giving them that's opening that question up to them. So they don't need to go into the algebra. They don't need to do it in a more formal way. Just looking for any other questions.
Yeah, Naomi, actually, that might lead quite nicely into that question that we had from earlier from Gemma, which was her comment that she said, yeah, so I marked for GCSEs before, and her supervisor wasn't familiar with the bar models. How familiar are markers examiners with bar models now, and how would students be rewarded for using bar models as opposed to a more formal notation?
Yeah, so I was asked this at the Heads of Department conference a few years ago when I first did the bar modelling, and Graham was there, Graham Cummins, and he said that essentially what should happen at that point is that it is a recognised method, and that actually what it should be doing is it should be escalated to sort of set up the chain, the marking chain essentially. Yeah. That there's nothing wrong with the bar model being used as a method, and if it's one that's not recognised by the marker or by the team leader or whatever, it should just keep being escalated up.
Yeah, absolutely. I mean, from my time in assessment as well, when I used to look after some of the in-series delivery, I know it's something certainly that the senior examiners have spoken about, alternative methods such as bar modelling. And so there is that knowledge within the examining team, but yeah, as with any sort of unfamiliar notation, those things should get passed up the line, and yeah, and students will be fully rewarded for for correct working, which obviously this is. So yeah, they absolutely will get rewarded for showing their working by this method.
Seb, I don't know if you want to answer that question that's just come through from Gemma.
So yeah, so do examiners get trained on it so that the examiner automatically gives no marks if they're not familiar with what? Well, the part of the examiner training should be that if there is an unfamiliar approach that's taken, then the examiner seeks advice from those above. And again, if it remains unfamiliar, then there's a sort of chain of command. All of these questions, I don't want to go into the intricacies of our marking system, but in technical terms, those questions that sort of example, they may be marked initially as 0, but should be put into a review so that a more senior examiner can take a look at it before any marks are formalised and put into the system. It is something that has this alternative approaches is something that's come much more into certainly the senior examiner training in recent years, since the reform GCSE came out. There was an increase in variety of approaches, and so that was definitely something that was highlighted, and examiners have been trained further on. So yeah, hopefully we'll see yes, a broader acceptance of those in the first case, but if not, then yeah, systems are in place to pick those up.
Yeah, okay, thanks Seb. Any more questions? If the website, somebody I think was did I see? I know it was me that mentioned it. Was it Maths? The Maths, I'll put it in the chat as well. Mathsbot.com was the website that I suggested. I'll just pop it in the chat. There you go. That's like I say, that's my go-to for getting all the pictures and the manipulatives for the website and things. It's a really good website for that kind. There's all sorts of stuff on there, but actually for the manipulatives, it's a time saver. So you don't have to go on PowerPoint and draw circles and cut, copy and paste each time. And with the double-sided counters, you can flip them on the screen. You can just click on them and it turns them round, or you can randomize them and so on. So that's a really good website to go to for that. Okay, well, if there's no more questions, I shall hand back over to Seb. But thank you very much, everybody, for your engagement, and I hope that was useful. I hope that sort of took it that little bit further than we did in the initial session. If anybody would like any more examples or anything, I can put together, I'll put together a couple of examples to go out with this package for the dividing on a number line as well, because I think a couple of people have asked about that, so I can do that, no problem. I can put that and send that through to Seb to go with this presentation.